3D Jewelry Blender 4.3 Modeling Tutorial.
Spherical diamond pavé clasp.
Add mesh, sphere, 80 segments, 40 rings. Dimensions 20 millimeters. Go to edit mode, Alt Z, Alt A, B, select the bottom vertices. Delete vertices. Exit edit mode. Save and be happy. Go to modifiers, add modifier, generate, solidify, thickness 1.2 millimeters. Control A, apply, scale. Go to the solidify modifier submenu, apply modifier. Go to edit mode. B, select the bottom vertices. Scale on the z-axis to 0. Go to global coordinates, XYZ to 0. Exit edit mode. Save and bring a 2 millimeter diamond. Add mesh torus. Major segments 50. Minor segments 25. Major radius 2. Minor radius 0.618. Align to the view. Move into position to the top of the sphere. Save. Add mesh plane. Align to the view. Size 0.618. Place it precisely to the right side of the sphere like this. Go to edit mode. Delete only faces. Exit edit mode. Add modifier, generate, screw on the z-axis. Control A, all transforms. Steps viewport 60. Render 60. Normals, calculate order. Add modifier, generate bevel. Amount 0.05. Add modifier, generate subdivision surface, level 3. Go back to the bevel modifier, segment 3. If your normals are still wrong on the red side, go to the screw modifier, normals, flip, save. Shift D. Make a copy of this border. Go to edit mode, select everything with A, grab and go to the top. S to scale. Make it twice bigger. Rotate 15 degrees to the right. Let half of the square come out of the metal like this at the top. Exit edit mode, save. Select the diamond and move it to the side at the same level than the border. The tip of the diamond should not come out on the inside of the sphere. Add empty plane axis, locate it to 0. Call it empty range 001. Select the diamond, add modifier, generate array. Object offset, empty range 001. Control A, all transforms. Select the empty, start rotating the empty on the z-axis. Our first angle will be 30 degrees. Select the diamond, adapt the count, 360 degrees divided by 30 degrees. This is our first range. Save. Select the diamond, make a copy, Shift D. Front view, go to edit mode. Select everything with A. Grab, rotate, and adapt the position. Come very close to the edge of the other diamond, but don't touch it. Exit edit mode. Select the empty range 001. Make a copy, Shift D. Select the second range diamond. Again, object offset, empty range 002. Select the empty range 002 again. Adapt the rotation. Mine will be 20 degrees. Select the second range diamond. Again, adapt the count. 360 degrees divided by 20 degrees. Top view. Select the empty range 002 and the second range of diamonds in the outliner, pressing the Control key. In the viewport, rotate and adapt the position to alternate the diamonds. My angle will be 10 degrees. Save and be happy. And now we're going to make the next ranges of diamonds. And what you need to know so you can complete this tutorial and be happy, the size of the gemstones and the size of your jewel are going to affect the angles for the distribution of the diamonds for each row. So it means that you need to find your own solutions. And at first, we don't know if the diamonds are going to properly cover the entire surface of the sphere. But don't worry, it's part of the process. When getting close to the border, we will take the pertinent decisions. Now, to make the third range, I'm going to take the first range and its corresponding empty. I'm going to make a copy, Shift D. In the modifiers for the third range, check that the object offset is correctly the third and new empty that we've just copied. Now let's go to the front view. Let's go to edit mode, select everything with A, grab the gem, adjust the rotation, and come close to the previous range. Exit edit mode. Now select the third empty, search for the proper angle, check that the gems fit. On the array count, I will go at 360 degrees divided by 16 degrees, enter. This is obviously failing. The diamonds are overlapping. So you understand at once that we will need an even count. So this range will have 22 diamonds. So let's take the empty number 3. Let's go at 260 degrees divided by 22. So now the rotation is not a whole number anymore. It's a fractional number. But obviously the important element is that the count for the diamonds is a whole number, an even number, and you don't try to put fractional diamonds around your jewel. Save and be happy. Now let's make range number 4. Let's select diamonds first range and the first empty. Let's make a copy, Shift D. Now front view, let's go edit mode on the diamonds, select everything with A, grab, adapt the position and rotate to adapt this new range. Let's come close to the previous range as always. This is good. Let's exit edit mode. Now select the empty range number 4, search for the proper multiplying rotation and check the count for the diamonds. Go back to the empty range number 4 and try the new input, 360 degrees divided by 26. So now we need to alternate the diamonds. Before we do that, let's go back to range number 3 on the empty. Here we have this Z rotation. Make a copy of this number and now go back to range number 4 and the empty number 4. Let's rotate from the top view on the Z-axis. The angle to alternate the diamonds is going to be the angle from the previous range. So let's paste the Z rotation of the previous range like I did just now and divide it by 2 to alternate the diamonds. Save and be happy. We still have more ranges to go. Let's select range number 1, empty number 1, Shift D, make a copy. On the diamonds, go to edit mode, select everything with A, grab and rotate. Adapt the rotation and come close to the previous diamond. Exit edit mode, take the empty range number 5, find a proper angle. In the array modifier, adapt the count of the range number 5. 360 degrees divided by 12.5, that's 29. Let's lower it to the even number. We'll have 28 diamonds here. Go back to the empty for the range number 5. Adapt the rotation, 360 divided by 28. Save and be happy. Let's make range number 6. So let's select range number 1 and the empty number 1. Shift D, make a copy. Front view, diamonds, edit mode, select everything, grab, rotate, adapt the position and the rotation for the diamond, exit edit mode, select the empty number 6, find the proper rotation. Here I have 12 degrees, select the diamonds, array modifier count, 360 divided by 12 degrees, that's 30 diamonds. Now this range is going to alternate, so take the rotation of the previous range, then select the diamonds range number 6 and the empty range number 6, rotate on the Z-axis by the previous angle, paste it and divide it by 2 so the diamonds alternate. The diamonds are perfectly covering the entire surface of my spherical Cartier diamond pavé clasp. And guess what? This is absolute luck. So to get the complete story, if you need to correct the distance between the ranges on the odd ranges that are not the alternating ranges, that's super easy, barely an inconvenience. You select these ranges and go to edit mode. Here you can adapt the position and rotation of your diamonds and then readapt the angles on the empty and the count on the array if necessary. That's for the odd ranges that don't alternate. But for the even alternating ranges, remember they have a rotation on the z-axis, on the diamonds, and on the empty range. So you cannot come to edit mode and simply rearrange the position and rotation of this diamond. It already has a 3D rotation on all the axes. So you will have to reset the rotation on the z-axis to 0 for the diamonds. Now I can go to edit mode, readapt the position of the range, and reset the rotation to the former rotation or whatever new rotation that will apply to the corrections. In practice, it's not really complicated. Now we're going to make the cutters and the boolean on the half sphere. Let's select all the ranges of diamonds. Here, make a copy, Shift D, Enter, convert to mesh, Control J to join. Call these cutters diamonds. I will add a solidify modifier to the outside, offset 1, thickness 0.06. Now I need a remesh modifier. I like a voxel size of 0.05. I can hide the cutters. Now let's take the solid half sphere. Let me add the Boolean difference fast solver, and let's remove the cutters from the sphere to properly carve the position of the diamonds. Here the Boolean is sensationally failing. It's very interesting, but that won't serve the purpose. So add a remesh modifier. Before the Boolean, I will use a voxel size of 0.04 with a smooth shading, so the Boolean delivers a perfect result. Let's go back to the general view, and we can see that the diamonds are now perfectly shining. Save and be shiny. So now it's time to create the prongs. Let's go to the top view. Let's add a mesh sphere. So at 60 segments and 30 rings. The size depends on the size of your jewel and the size of the diamonds. I will start at 0.8 millimeters. Material gold at once. Now let's zoom in the prong, front view, edit mode, and let's extend this part of the prong. Select everything and readapt the center of gravity a bit above the center, somewhere like this. Now exit edit mode. That's prong 001. So let's turn on the snap to center, face project, align rotation to target, affect move and rotate, and turn the snap on. So now we can start, grab it, and test the position. This is good. Now let's make a copy, Shift D. We're going to share these prongs on the first range. Now take one prong, make a copy, put it anywhere you like. Always make a copy of your prong to safeguard the original prong. Now we can take these two prongs, join them, Control J. These are going to be prongs range 1. Do a Control A, all transforms. Now select the prongs, select the diamonds from the range number 1, go to Object, Link, Copy Modifiers. So these prongs are going to have the same multiplier than the diamonds for the same range. That's obviously working. Good, let's make the prongs for the range number 2. So let's make another copy, Shift D. Here at the center, there's only a rotation on the y-axis for these prongs. So now let's make the safeguard copy. Now we can take these two prongs, join them, Control J, Control A, apply all transforms. Now here for these prongs, we can't use the same array than the diamonds because these diamonds, they have a rotation on the z-axis, and these prongs, they won't have any rotation on the z-axis. So we need to take the empty of the range number 2, make a copy of it, call it range number 2 prongs. These prongs are going to get an array modifier based on the range number 2 prongs. Now, the angle is going to be double the angle, and let's go merry-go-round the sphere. Here we are. We have the same count for the prongs than the diamonds. Range 2 is ready. Save and be happy. Now let's work on the third range. So the prong is here. Check that the snap is turned on. Adapt the position. make a copy, sharing the prong, make the safeguard copy, take the 2 prongs for the range number 3, join, Control A, all transforms, put the name to the ranges. This is range number 3. Now you will see that on odd ranges, like range number 3, you can select the diamonds and copy the modifiers to the prong. The result will be correct. If you don't believe me, let's go merry-go-round the sphere again, this time with the view. And we can see that the prongs are properly setting the diamonds. Range 3 is ready. Save and be happy. Time for range number 4. Snap is on, the prong is here. I will move it to the right side. Let's make a copy down here. Make the safeguard copy. Select the 2 prongs for the range. Join, Control J, Control A, all transforms. Make a copy of the empty for the range 4. This empty will be for the prongs. Select the prongs for the range 4. Put the array modifier from the object offset for the range 4 prongs. Now for the rotation on the z-axis, select the diamonds and check the count. We have 26 diamonds on the range number 4. So for the empty for the prongs of the range number 4, the rotation must be 360 degrees divided by 26. And on the prongs, the count must be 26. And range number 4 is ready. Save and be happy. Now ready for range number 5. Check the snap. You already know the story. Check the position. From the top view, I prefer to go to the right side position. Copy the prong. Safeguard copy. Take the prongs. Join them. Control A. All transforms. Select the diamonds. Object. Link. Copy modifiers. Range 5 is done. Save and be happy. Time for the last range, range number 6. Check the position of your prong, make a copy, center it, take the prongs, Control J, Control A, all transforms. Now we need an empty from the range number 6. Copy the empty for the prongs of the range 6. Check the count, 30 diamonds. So the Z rotation is going to be 360 divided by 30. That's going to be 12 degrees. And the array on the prongs from the empty for the range number 6, count 30. Let's go merry-go-round our diamond Pavé spherical clasp to check that everything is in order. Save and be happy. Now it's the time for small aesthetical adjustments. I've adapted the design of the top part, closing the middle, adapting the position of the loop to the side view. And down here, I've added a small ridge to this border. Small aesthetical elements. Now we're ready to make the entire clasp. So let's create 2 collections. Half 1, half 2. Now you can hide all the empty elements. This will allow you to select the entire half sphere and make a copy, Shift D. This is our copy, convert to mesh, applying all the modifiers, join, Control J, and this is half 001. You can move this to the half 1 collection. Now let's make a copy of this half. Don't forget to reset all the transformations. Control A, apply. Now let's make a copy of this half, Shift D, move the copy to the other half 2 collection. And we're going to rotate it 180 degrees on the x-axis. But we need to alternate this second half to avoid having parallel diamonds. Parallel diamonds in this type of designs don't look good, so we need to avoid them. Let's go to edit mode, deselect everything, but keep the hoop separated, key, separate selection, because the loop will not rotate. Exit edit mode. So now we need to find a proper Z rotation for this half. Remember, the count for the diamonds of the last range is 30 in my case. So it means that the proper Z rotation to alternate is going to be 360 degrees divided by 30. That's going to be 12. And we need to divide this by 2 to properly alternate each half. Now this is great. The exterior of the clasp is complete. it means that it's time to make the interior mechanism to complete the clasp. So now for visibility and modeling comfort, I'm going to stay with just half of the sphere, add mesh plane to the view, and I'm going to select the sphere also, and let's go to edit mode, X-rays. So from this, I'm going to scale it halfway, move it 0.5, so we have 1 millimeter thickness. This will be at 0. Let's delete this edge. It's going to be open right here. And now on the side view, let's go to the exact edge of the sphere. So with the transparency, I can see exactly the interior wall right here. So at the top, very close to the edge, and at the bottom, very close to the edge. Let's make a slight bevel on the vertex here, very slight, 0.05, 5 segments, and here also a very slight bevel on this vertex, 0.05. That's pretty nice. Now, the interior has a slight curvature, so let's subdivide this 3 times. Let's come close to the interior wall to follow the inside curvature of the sphere. A bit closer there. Let's check the bottom. Select these vertices a bit closer. Now, exit edit mode. Control A, apply all transforms, add modifier, screw modifier on the z-axis. Let's make 100 steps like this. Don't forget to merge. Then add a bevel modifier, 2 segments. That's to keep the precision of this piece of the mechanism. Make the amount really small. Don't forget to check the face orientation and calculate the order of the normals on the screw modifier. This is clean. And now I can make a copy of this plate, Shift D, and rotate 180 degrees. That will be the bottom plate. Save and be happy. Now make a Shift S, cursor to selected. Copy the Y dimension of your plate. On the y-axis location of the 3D cursor, paste the measure you just took from the plate and divide it by 2. That is going to be exactly half the radius position for the knobs. So add mesh cylinder. Use a dimension of 1 millimeter. Let's go to edit mode. Take the bottom, Z position minus 1 millimeter. That's exactly at the thickness of the plate. Do a Shift S, cursor to selected, add a UV sphere, 50 segments, 25 rings, radius 0.75. Now zoom in. First, we're going to put the sphere exactly at the intersection of the surface here. And if you want to be very, very precise, go to the maximum zoom. That's already a microscopic scale in real life. This is good. Now from here, we're going to grab the sphere and we're going to move the sphere up 0.025 millimeters. That's 2.5 centesimals. Higher than the exact intersecting position. That means that now the sphere is going to press the plate very slightly, and this will give your clasp some strength, and that will require you to make a small pushing force on the clasp to rotate it and to take it out. So the sphere must be very, very slightly forced onto the plate. Exit edit mode. Call this knob 001, and now add a mirror modifier on the y-axis from the top plate. The knobs are going to be part of the top plate. Save and be happy. Now, obviously, these are made of gold. Now make a Shift S, cursor to selected, add mesh cylinder, 120 vertices, radius 0.5. Grab it on the z-axis and move it by 0.75. That's the guiding center knob belonging to the bottom plate. It will be made of gold, and we can give it a small bevel modifier at 0.05. And obviously it must stick out to properly guide the center of the clasp. And now starts the very interesting part of this tutorial. We must make the cuts to create the mechanism of this push rotation clasp. and make it a functional yet beautiful reality. So let's take the knobs, let's make a copy, let's go to edit mode and erase the sphere. Select everything, scale it on the z-axis, way more than needed. Now convert to mesh, Control A, all transform. These will be guiding path cutters. Now let's add an empty axis, call this path multiplier. Take the guides, add an array modifier based on the path multiplier. Now let's take the path multiplier. Now we're going to rotate this path multiplier by only 1 degree on the z-axis. Then we're going to select the guides so we can create 120 degrees cutters by using a count of 120 on the array of the guides, and the empty path multiplier is going to multiply that by 1 degree each time. So now we have 120 degrees path cutters. So on the bottom plate, we must now add a Boolean modifier, fast solver, and cut the guiding. This is not working for obvious topology reasons. So here on the plate, let's add a remesh modifier before the Boolean. I'm going to use a voxel size of 0.5 with smooth shading. And now also obviously the guiding path after the array, they need a remesh modifier to make the Boolean perfectly fine and beautiful. Save and be happy. So now we must cut the entries for the spheres. Let's take the knobs. Let's make a new copy. Let's go to edit mode. Remember, the sphere had a radius of 0.75, so it means that the spheres are 1.5 millimeters in diameter. We can erase the spheres. We can select the cylinder. Let's scale it 1.5 times and let's make it a lot bigger on the z-axis. So now let's take the plate, add Boolean fast solver, and let's remove these cutters. That's the cut for the entry of the spheres at the starting position. And here's something important for the orientation. At this point, it's good to make a copy of this plate, turn it into a mesh, and adapt the orientation. These are the entry points and also the exit points. And this means that the orientation of the plate is wrong, because what we want here in the closed position when aligned to the hoops of the clasp, it means that we need to rotate the bottom plate back from the 120 degrees. So you can properly open the clasp by rotating 120 degrees to the exit position. Now on the top plate, let's add a remesh modifier, 0.5 voxel size, smooth shading. And now we're going to add a Boolean modifier because we need a fast difference from the centering knob belonging to the bottom plate here. And now we need yet a very small but important technical detail. Let's take the knobs, let's make a new copy. Let's go to edit mode, but now we're going to erase the cylinder and keep the sphere. Let's convert it to mesh, do Control A, all transforms, and we're going to rotate the spheres to their ending position. That's 120 degrees on the z-axis. We're going to see that they're slightly touching the plate, and that's exactly what we wanted, because like I said earlier, the very slight pressure from the recessed sphere, remember we moved it back on the z-axis, so it makes pressure on the plate. So what we need now at the ending position is yet another Boolean on the bottom plate, fast difference, and remove these spheres. And we're going to see that they are marking a very small yet very important ending position. That's where they can click in. So here we can yet adjust the strength of the ending position by moving the spheres on the z-axis, maybe another 5 centesimals. Obviously, this is always very tricky to adjust because it depends on the real life jewel. So generally what we do with these types of mechanisms is that we print prototypes and we make the casting in brass to test the mechanism to the exact real life measurements. And once the prototypes are working, we make the casting in brass. Brass is a perfect metal to test jewels in real life because brass is a very precise and tough metal, and that's perfect for testing mechanisms in real life for jewelry design and jewelry making. Now here, the mechanism is complete, top plate and the bottom plate with the correct cuts, knobs positioning, and what we're going to do here is a small animation for people who have never seen this type of clasp in real life to help them understand better the basic principle at work in this push rotation clasp.